Good afternoon, guys. Okay, for the first half an hour of the session, we are going to quickly look at the software engineering material from this, and then we're going to step over another stuff for the other guys. Then you'll be excused for the software engineering students. Now, what I take from this is what you are going to be doing for looking at this week is the analysis and design overview. So you will see the slides is now available, and then use case design. Now, we are going to look at a few things from it. We're not going to look at all of it, as you can go through it on your own also. Now, as this is a transformation really from analysis later on to design, what we are focusing more is the transformation from this. Now, where we're going is to go and create a design model, a data model, particularly for that, and then also to look at an architecture document for that. So the purpose of the analysis and design you will see is to translate and to transform the requirements into a design of the system to be, and then to evolve and to form a robust architecture for the system. Okay. So also then to adapt the design to match our implementation environment. So that ultimately what we are designing for matches our implementation architecture and environment. Okay. There's a bit about the workflow and areas about it. Now, what you'll see, there's a quick comparison between analysis and design. During analysis, the focus initially was just on understanding the problem, but we're now translating more to a solution perspective, where we're also starting to focus on the actual operations and attributes, the actual how is it going to be performing. Then also it's going to be a lot closer to the real code, as we're starting also to take consideration the implementation language. Okay. Now, there's a bit of information about who's doing this and what is their outputs and so on. You can look at that, and there's a bit about the reviewing of analysis design, the top-down, bottom-up approach, which it's not really, but it's more method that we're going from a use case perspective, and we can go either an upwards perspective where we're looking high level, where you start to create functional areas in your subsystems and areas which brings classes together, or you can go into the actual minute detail at class level, where we're going into design classes. Then they also mention about, again, the iterative process of design. Okay, but where I want to get into is this. What they mention is here is a what is architecture. Okay. When you build a building, what do you have to design the building? What do they have? Some form of a blueprint. Some document that states what is going where. Where is the concrete going to be thrown? What is the rebar that is being used? The watering, the lights. It's a document that tells them how will the project be designed. And even when you design a software system, you will see we are now looking at the software architecture document. Now, this tells us that we have a set of some significant decisions about how we are organizing our software system. So it's some important decisions which we are making and helping us to design and say, but how are we structuring our software system, and what are we placing where? Okay. Now, in your case, you will not be required to make this decision, but we will be designing for a given architecture. Okay. So we'll also get to a place of discussing that a bit. Okay. So you'll see it gets down that we're now saying that we need to look at the selection of the structural elements and possibly the interfaces and how the system is going to be composed to use them. Okay. Then we're also looking at the behavior as specified between the collaboration among those elements. How are the classes or objects really be used? Okay. Then the composition of our structural and behavioral elements possibly even into a larger system. How is it being put together to create our total system? Then lastly, it also needs to look at the architectural style that guides this organization and the design process. Okay. So those are the main things which we are looking for when we creating and we're starting to look at the architecture. Okay. Guys, any questions about architecture to this point? Why is architecture important? Why is architecture important? And I mentioned what is architecture, but why is it important? Okay. Now, by looking at this, what it's telling us that we have some form of pyramid that's going on. The architecture is important because we get to a place that's saying that our architecture underpins your whole design and implementation later on. What do we mean by that? Is that our architecture, the underpinning portion, if you have that totally correct for the system which you are designing, your design and the implementation will be nice and working correctly. But what happens if a building's architecture is incorrect? The building can fall over or something is incorrect about it and you have to fix it later on and it's costing a lot of money. What happens if a software system's architecture is incorrect? It is very possible that it won't work, or it's going to cost a lot of money to fix later on. Let's say, for example, you were to develop the system for the vehicle tracking through the e-toll, and you've put up the scanners now over the road, but you cannot read the data. Will the client be happy with you? Let's say you decided to use some components which is outdated and it's not being used anymore. Is your system still relevant? Can it be used? Can it be maintained? So those are questions which you might need to look at during your architecture. So that's why we're saying that it's some important decisions which we're looking at early on. So that whenever we design this, we can get to the actual design for this and design according to our architecture. Okay. So then it goes over to say, but we get to a place of saying that there's a 4+1 view or model of our system, and we are looking at different components or different perspectives of our system when designing this. You can look at a logical implementation or deployment or process, but the main one which stays from all this is your use case view. Because for everybody who's part of the system, they are looking at the use case, the actual end functionality. Are they getting the use case which they said, this is the functionality of the system which they want? Are they going to get it? Okay, so for the logical analysis, the analyst and designer is worried about that. How is it structured? Okay. They are worried about that. Then the implementation view, that's where the program is looking at, and he's looking at what must be coded. Okay, so the deployment talks about the arrangement of the software system. What component is running where? If you have a system that is structured on multiple servers even, or multiple connections or endpoints, then you might need to look at what is running away in terms of your deployment. Our process view can look at the integration, your scalability of it. That's where the performance and throughput also comes to play, and you might need to look at that. Okay. Guys, you'll note that there's a few review questions at the end of this. about the architecture and so. Okay. Now, the next unit then speaks about use case design. So, what is the difference between analysis and design? Firstly, it's getting into the fact that we're starting to look at more detail. We're now basing this on the actual architecture. We're starting to look at the actual classes based on that architecture. Okay. Will our classes be the same if we're designing for an embedded system compared to a mobile system and even a web-based system? Will the classes be the same? Guys, you're busy with programming. Will your operations and attributes be the same? No, they are different. So that's where we're getting to, is that we're now starting to look at that based on the actual architecture. So during use case design, we're going to look at a bit of this. So you'll see, ultimately, we are taking in the supplementary specification, the use case, our design classes, and even our systems and interfaces to go and enhance our use case realization. Okay. Now, what does this mean? We are taking our analysis classes and we are expanding them. What was the guidelines initially for a boundary clause? It was nice and easy to say, but we have one boundary clause per active use case pair. But is that always going to be the same? Can he actually use multiple buttons to start a system? Multiple user interfaces? Yes. That is now where we're starting to say, but for our boundary clause, we might have multiple classes doing that. Okay, even a control clause can be split into multiple portions. Okay, the entity class stays a bit more consistent in all of this. Okay, so you'll see there's a bit of mention about the steps. Again, like an analysis, we're developing a design use case realization. We're now then going to look at describing the action among our design objects. Then we look a bit about simplifying the sequence diagram using subsystems, describing persistent related behavior. Okay, so those are some of the things from this. Okay, there's a mention about the use case realization again and about creating it in the design. So what do we mean by describing the interaction among design objects? We are going to look at how these objects are working together to solve a particular problem, how they are getting together and working on that. Okay. So some of the things that we might need to look at is we are going to look at our objects which is participating in that particular use case, and that will help us to identify the actual lifelines and classes that we might have in our diagram. Then we will allocate our responsibilities among those objects based on it. Then we'll also model our messages between the objects, and we'll describe the processing resulting from the messages. Okay. So some of those realization refinement steps that we might have is to break it down and go through it incrementally, and even possibly break your steps in your sequence diagram to include subflows and so for you. Okay. Guys, do you have questions? You are quiet today. Okay. Then there's also mention about what the difference between using interface classes and proxy classes. Now, you'll see here at the bottom that just shows to us the valid and invalid ways that we can then start to use them. For example, if we have an interface, we cannot really represent model elements that realize that interface. And then no message should be drawn from the actual interface. Okay, these interfaces, what we're talking about is actual interfaces to other systems. So we're not going into say, but how is the rest of the system working? What is the details of that subsystem that we're talking about? Okay. Then if we have a proxy class, it can represent specific subsystems to us, and our messages can be drawn, in this case, from our proxy class to say, but this class will be doing things for us from here on. Okay. So what you will see is that we are, in essence, looking at the translation from our analysis classes to design, to expand this in more detail. Okay. Now next week we will be looking at the actual architecture and how to do this based on the architecture which you will be working with for this semester. Okay. Now in this case, they've just mentioned to us that we have a billing system, and to actually get to the billing system we need to go through a interface. And then there's also a course catalog system, and they are then going to the course catalog system through that specific interface, getting in there into the subsystem. So there's also mention about the design sequence diagram and the expansion of it. So you'll see they've now included in the diagram just that specific subsystem and in the diagram. So they also mention a bit about how does it look when we incorporate this in our class diagram. Okay. Now, one of the things I want to get to is the discussion about using subsystems. Guys, have you used subsystems in your programming? You would have seen it if you've read through it at some point. Now, subsystem is really a container, and in that you can have multiple other classes. Okay. Now, why would we do this? Why would we have a subsystem in our design? If we, for example, have a section of flow in your sequence diagram which is very complex, and you start to realize, but this can be broken down into more steps. Your initial diagram might just say one message to you, but this later on can be translated into multiple other messages. Okay, so that's why they're saying to us, for example, this one can be translated into its own sequence diagram. And even this one, we can create our own interaction diagrams for this and expand it when we go through it. Okay. So when are we going to encapsulate a subflow and start to use it? If some flows occur in multiple use case realizations, if that specific steps are happening in multiple use cases and we're starting to have a possibility of reuse, to use it over and over again. Okay. If it is complex and then can be easily encapsulated into another section for us. Okay. If it's possibly the responsibility of one person or a team, it allows us to make that subsystem the responsibility of either that one person or the team of people. Okay. Because we then created based on the team, it can allow us to have a well-defined result. Okay. It also allows us to implement that and then to move a bit away from it. Okay. Now, what you would have seen from this is that in your programming so far, I don't think you've really seen it or used it in C++. Okay. Now there's a possibility for this, and we'll get to it a bit later, that you can have one class or a package and you can start to reference others from there and incorporate it in your work. So there's also a bit about the mentions of the advantages to this and how it allows us to use parallel systems development from a perspective. Because we can then have multiple groups of people working on that, it can cut down the time on it. Okay. Guys, any questions? So what you will note from the material for this week is more of a theoretical introduction to it. We will be doing the real design from next week onwards, where we're actually starting to look at the actual architecture, and then based on that, we'll be designing the actual sequence diagrams and class diagrams from that point onwards. Okay. Any other questions? What type of system are you going to be working with this semester? From programming, what system are you working with? The? NetBeans is not a system. That's an IDE. That's the development environment you can use to design a system. What was mentioned to you by Mr. Bosman? An elevator. Okay, we are going to be looking at designing an elevator. Okay. Okay, so we look at some of those use cases in some portions of the actual design, but we'll be introducing some of the architectural components for that during the time. Okay. So guys, thank you.